Sometimes the biggest stories about our planet, well, they aren't told by us. They're told by the smallest of creatures. Today, we're going to dive into a wild tale of catastrophe and, believe it or not, incredible resilience. It's a story that was literally written in the sand by a bunch of tiny crabs. And it all kicks off with one of the most powerful natural disasters in modern history. So that's the big question, right? When the very foundation of an ecosystem gets shaken to its core, what happens? What clues do its inhabitants leave behind about how to survive? Because this disaster created a massive, unplanned, natural experiment. Our story starts on a day many of us will never forget, December 26, 2004. We remember the devastating tsunami, of course, but those massive waves, they were just a symptom. The cause was something way more profound, a colossal 9.3 magnitude earthquake that didn't just move water, it physically ruptured and shifted the Earth's crust. And for our story, ground zero is right here, the Andaman Islands in India. This remote chain of islands became this completely unintentional laboratory, a place where scientists could see, firsthand, the immediate aftermath of a sudden, dramatic change in sea level. Okay, so here's the really key thing to get. The earthquake didn't just do one thing. It did two totally opposite things depending on where you were. In some spots, the land was violently shoved upwards. That's a process called uplift. And what happens when the land goes up? The local sea level drops. But then in other places, the land actually sank, it subsided. And there, the sea rushed in, causing the local sea level to rise. So you've got these two extreme opposite scenarios happening at the exact same time. It's wild. So to understand what happened next, we really need to meet our main characters. And they weren't just passive victims here. Oh no. They are the tiny engineers that build and maintain this entire coastal world, the mangrove crabs. Mangrove crabs are what scientists call ecosystem engineers. Think about that. Their constant burrowing and feeding is absolutely essential work. They're like the gardeners and plumbers of the mangroves, cycling nutrients and aerating the soil, which keeps the whole forest healthy. This makes them the perfect witnesses for the chaos that was about to unfold. Before we get into the chaos, though, we need a before picture. Take a look at this. This is our control site, a healthy, totally normal mangroves in the Andamans. You can see it's this complex, thriving world with different zones, stretching from the forest deep inland all the way out to the sea. And what's just fascinating is how organized this little world is. This chart shows you where all the different crab species hang out. Each line is a different species, and you can see they aren't just scattered everywhere. Nope. They occupy these very specific zones. Some live near the land, some in the middle, some out by the sea. Each one is perfectly adapted to its own little neighborhood. This is what a healthy system is supposed to look like. And just look at the sheer biodiversity here. In this one, single, undisturbed spot, scientists found 57 distinct species of crab. 57. That's an incredible richness of life, all living in this delicate balance. I want you to burn that number into your brain. 57. All right, now we have our baseline. So let's turn to the first crime scene. We're heading to the parts of the islands that were violently shoved upwards, where the sea was suddenly forced to just pull back. The impact of this uplift was immediate and, honestly, brutal. That critical zone that gets washed by the tides every day, well, now it was permanently high and dry. Starved of seawater, pretty much all the mangrove trees died. The crab's entire home was just gone, wiped out. So what happened to the crabs? Did they just vanish? No. The survivors did something amazing. The whole community reorganized itself, shifting seaward, literally following the retreating water. This collective march towards the new coastline has a name. It's called progradation. They were chasing the world they had lost. Now for our second crime scene, let's look at what happened where the exact opposite occurred, where the land sank and the sea came rushing in. So here, in these subsided sites, the sea didn't retreat, it invaded. The rising water just pushed inland, drowning the edge of the mangrove forest and turning it into a swamp filled with the dead and dying trees. A totally different kind of destruction. And once again, the crabs responded with this predictable, organized movement. This time they retreated away from the invading sea, shifting landward to escape the flood. And this process is called transgression. What's really interesting is that all this new dead wood actually created new habitats, and certain species that love decaying logs really started to thrive. And this is where it all comes together. This one chart, man, it just says it all. So remember that number 57? That was our healthy, untouched control site, that bar on the far left. Now look at the middle. In the places that got flooded, the subsided sites, biodiversity definitely took a hit, but it's still pretty high, right? Around 50 species. But the real shocker is that bar on the right. In the uplifted sites, the ones that dried out, the number of species just plummeted to 28. That's over half of them just gone. It turns out drying out the coast was way, way more devastating than flooding it. So, after piecing together all the clues from our two very different crime scenes, what does this amazing story of survival actually tell us? What's the big takeaway from this massive, unintentional experiment? Well, first, it reveals that the response to catastrophe isn't just random chaos, it's predictable. When the land rose and the sea pulled back, the crabs marched forward in progradation. When the land sank and the sea advanced, they retreated inland in transgression. These were organized community-wide responses. They knew what to do. And that right there is the core lesson. This wasn't just a story about destruction. It's a story of incredible resilience. The crabs basically gave us a living map, tracing the new boundaries of their world and showing us in real time how a complex ecosystem reorganizes itself when the rules suddenly change. And this really highlights their new importance to science. The researchers concluded that these crab species can now serve as models. By studying how they react, we can get a much better handle on predicting how coastal ecosystems all over the world might respond to future changes in sea level. And that's why this whole story matters so much. The 2004 earthquake was like a time machine. It took the slow, gradual process of sea level rise that's happening globally because of climate change, and it compressed it all into a single, terrifying, observable event. It gave us a powerful, if tragic, preview of the challenges our own coastlines are going to face. So we end up right back where we started, but with a totally new perspective. The story of the Andaman crabs is all about adaptation in the face of overwhelming change. And it leaves us with a really important question. If these tiny survivors could map out a path to resilience, what can they teach us about how to navigate the changes that are coming to our own world?